Alright, so permutations and probability. That's the topic for today. So permutations. Let's consider three letters A, B, C. So how many ways can you arrange the letters A, B, C? Okay. So let's look at that. So you could first put them in this exact order, A, B, C. Or you could choose to leave A in the first position but flip-flop the B and the C. Or we could let the letter B jump in line and then flip-flop. Or we could let the letter C jump in line and again flip-flop. So we have 6 ways to be able to rearrange those particular letters A, B, C. Now, this ordering of objects is called a permutation. So ordering of objects permutation. Okay. And the way that you find this number of options or number of ways that you can arrange these objects is found by what we call n factorial. Right. Some calculators have an n factorial, a little button that has the factorial. If not, you're going to have to do the work on your own. But what it says is that you are writing in descending order n times n minus 1 times n minus 2 all the way down to the numbers 3 times 2 times 1. So it's a decreasing multiplication starting with the number n. So for example, up here I have my n is 3. There are 3 objects that I want to be able to rearrange. And so the number of ways is going to end up being 3 factorial. If I expand that out, that means 3 times 2 times 1. And when I multiply all of those, I get 6. So there are 6 ways to rearrange these letters, which is the same as 3 factorial. Now we can do this with just about any situation. So we're going to have a lot of applications. So consider that a radio station has 8 songs to play. Right? Now, if a radio station has 8 songs, they can put them in any order they want. Well, this is called a permutation. I want to know how many ways can they play these songs, like what order. How many ways can they play these 8 songs? Right. Well, that's huge. And again, the number of ways, I'm really thinking about if I have 8 options for the first song, then 7, then 6, 5, 4, and so on. So the number of ways is going to be 8 factorial. So if you put that into your calculator, again, if you don't have the factorial button, you're going to have to actually multiply all of these descending numbers out. And it's kind of crazy. You end up with 40,320 different ways that you could rearrange those 8 songs to play on the radio. Well, now, what if the DJ starts to have too much of a conversation and they can only play 5 of those 8 songs? So what if only 5 of the 8 songs can be played? Well, now I have 5 options. So I'm going to do these 5 little lines. And so in the first option, I have 8 songs that I could choose from. Well, once you play that song, you no longer have that as an option. So the second song, there's only 7 options, and 6, and 5, and then 4 options. So we only have these 5 songs to play, and so when you get down to the end, you're not going to be using this 3, 2, 1, because the last song you had 4 options and you just chose one. So when you have a certain number of items possible, and you only have a select or a specific number that you want to be able to choose from that, then you want to try to use these lines to think about your options. Now, if I multiply those through, I'm going to get 6,720 ways. So I have less ways to be able to choose those songs, but that's okay. It's kind of a good thing. And so the way that you're going to be able to kind of use this information, we have another little formula. What this is when you're taking permutations. If I want to take permutations of some number of objects taken, we call R at a time. All right, so that's what this is leading us into. So we get this formula. We call it NPR. And what that is that's the formula n factorial divided by n minus r factorial. And what this is going to do is it's going to allow us to take chunks or have options. So, for example, I want to know how many different ways can 4 prizes be given to 50 people. All right, and something that we're going to consider here or assume is that you can get at most 1 prize. All right, so we don't want one person to get all the prizes. So what we have is we have the total number of people in the group is 50. All right, that's going to be our n value. So it's the larger number here. So I have 50 possible in the group, and I want to choose 4 people at a time to earn the prizes. So this is your setup for your permutation with 50 objects, where I want to take 4 at a time for those objects. And so when I set this up, I'm going to have a 50 factorial over 50 minus 4 factorial. Now, the crazy thing with these is that you can't put that into your calculator. Those numbers are so large that your calculator will just shut down. All right. Well, let's simplify down this denominator with this really 46 factorial. So I'm going to start expanding. All right, you can see the numerator is bigger. So 50 times 49, 48, and so on. And I'm going to stop when I'm at the same factorial as what's in the denominator. All right. And the reason I'm going to do that is because that allows me to then cancel out all of those chunks. Because this is the same as 46, 45, 44, all the way down to 1, and so is the denominator. So they are the same factor, or they have the same number of terms. And now I can just multiply these 4 digits, or 4 numbers, in my calculator. That's still going to give me a large number. So with 50 people, if I want to be able to give them 4 at a time, give them prizes, I have over 5 million different combinations that I can use.